let us start. Today we will discuss the vapor compression refrigeration system. Vapor of the refrigerant, whatever refrigerant we use, that vapor will be compressed in the refrigeration system, and that is why it is called vapor compression refrigeration system. That means it is like steam only, but we do not use water as a refrigerant. Some other fluid is used, and the vapor of that fluid, like the steam of water, okay, the vapor phase of the liquid of the refrigerant is compressed. This is the refrigeration system that is used in all refrigerators that we use. If you have any refrigerator at your home, then that refrigerator uses this system of refrigeration called vapor compression refrigeration system. So the most used method of air conditioning of buildings or domestic and commercial refrigerator. This is the most commonly used refrigeration system that we will discuss. So the components, first we will discuss the components of the vapor compression refrigeration system. What are the main components required for refrigeration? Definitely we need one compressor that compresses the vapor phase of the refrigerant, and after a compressor it will go to the condenser to reject the heat. Compressor will compress. After that, because of the compression, the pressure is high, so that will be reduced by using one expansion valve. So this is basically like an expander in the air refrigeration system. So in place of expander, we will use one valve, and that is called the expansion valve. So what will the expansion valve do? It will reduce the pressure, and after that it will go to the evaporator. This is the actual refrigerator. Refrigerating effect will take place in the evaporator. So this is heat rejection. So what will happen in the evaporator? Here the heat will be absorbed in this evaporator. So these are the main components of vapor compression refrigeration system, and in between condenser and expansion valve there is one receiver that receives the liquid condensed by the condenser. So what is the function of the condenser? Condenser changes the vapor to the liquid. So basic principle is that the liquid is changed to vapor, and again vapor is changed to liquid. These are the two phases. Once it becomes liquid, and again it becomes vapor. So from evaporator it will come out as a vapor. Still it is vapor. Not only vapor, it will be superheated vapor. It is not dry, even superheated steam, like superheated steam. So from condenser it will go to the expansion valve, and we all know due to the expansion, temperature and pressure decreases. So since the temperature decreases, it will become liquid again. Okay, this liquid will be received in the receiver. That is like a storage of the liquid. The liquid is stored in the receiver, and that will go to the evaporator, where it will absorb the latent heat of evaporation at low temperature, and it will become vapor again. That is the cycle involved in the vapor compression refrigeration system. So suppose this is a compressor. The compressor will receive the vapor, because the system is vapor compression refrigeration system. So vapor refrigerant, that means vapor steam of the refrigerant will enter into the compressor through the intake valve or suction valve, and it will be compressed. If we compress a vapor, then what will happen? The pressure and temperature will increase, and that will make the vapor superheated vapor, superheated steam, like that. So after compression, it will go to the condenser for rejecting the heat, like cooler in the air refrigeration system. So definitely in the condenser, the cooling arrangement will be there. It may be air cooled or water cooled also. So what will happen if we cool the superheated vapor? It will reject the heat. So this is basically the heat rejection system. So if it reject the heat to the coolant, superheated steam, superheated vapor will become dry, and if it continue to reject heat, then it will become liquid gradually. So it will enter as a superheated steam, superheated vapor, and it will go out as liquid because of the heat rejection process. So where it will go? It should go to the receiver, where the liquid will be preserved or stored, better to say. Liquid is stored to be used for the next phase. It will come out as liquid. It enters as a superheated vapor after condensation, because what is the function of a condenser? To condense a vapor, change of phase from vapor to the liquid. Now if it is stored in a receiver, it will has to be used, but till now after compression it is high pressure. Till now it is high pressure because of the condenser pressure increases. So this is high pressure. This high pressure has to be reduced, and that is done by an expansion valve. So what it will do? It will reduce the pressure. The name implies expansion valve, means it will pass through a valve, and because of this the pressure will decrease. So what will happen if the pressure decreases? The refrigerant, which is liquid, now it will start evaporating because of the low pressure, and evaporation become easier. Okay, so now it should go to the evaporator. Okay, what is an evaporator? This is the refrigerating unit. In this place, the refrigeration will take place. So what is a refrigerator? A refrigerator absorbs heat at low temperature and reject heat at high temperature. Where it is rejected? In the condenser, and it will be absorbed in the. So this is what? This is heat absorption process at low temperature. So what will go? Where it will go? The after expansion valve, low pressure, low temperature, liquid vapor mixer will go to the evaporator. So what is this? This is liquid plus vapor. There will be more liquid and less vapor. So this is a low temperature region, and pressure is also very low. The liquid vapor mixer, that means the liquid part, will absorb the latent heat of vaporization. What will happen? The latent heat of vaporization will be absorbed, and if any liquid absorbs the latent heat of vaporization, then it become vapor. When it will go passes through the evaporator or refrigerator, it will come out as dry vapor. Okay, in the thermodynamics we discussed about what is dry steam, what is saturated water, what is saturated dry steam, what is superheated steam. This is like this. So this dry vapor will again enter into the compressor, and it will become superheated vapor, like superheated steam. And this way the cycle repeats. Okay, what are the components? Components are compressor, condenser, receiver, expansion valve. Before compression, this is called low pressure side, because after compression pressure will increase, but till now it is a low pressure vapor. So this is called, before compressor it is called low pressure side. There are two sides, one is low pressure side and another is high pressure side. So after compression it will become what? High pressure side. That means because of the compression, pressure increases. What is circulating in this system? The refrigerant used in a refrigerator. So this is basically dry vapor of refrigerant. That is, it is like dry steam coming out from the evaporator. Then after evaporation it becomes superheated steam, like superheated vapor. So it will go to the condenser. This component is condenser. So here the heat rejection will take place at high temperature. The superheated steam or vapor enter into the condenser and it will reject heat to the coolant and it will become liquid, and liquid will come out of the condenser. So this liquid will be, this is liquid, 100% liquid. So this is stored in a place called receiver. This is the receiver. So till now it is high pressure. You see, after compressor, condenser up to receiver, this is high pressure. Okay, this is high pressure side, and that is why we need one expansion valve where the pressure is reduced. Okay, because of the reduction in pressure by the expansion valve, the liquid start becoming vapor. At low pressure, evaporation become faster. The low pressure side begins from expansion valve onwards. From here it will be low pressure side, and it is liquid plus vapor. And this will enter into the refrigerator or evaporator. Refrigerator is also called the evaporator. Evaporator, it will absorb the latent heat of vaporization at low temperature, and it will become low temperature and low pressure, and it will become dry vapor. So it will be only vapor. Okay, it is liquid. It was what? Liquid plus, it was superheated steam. Now after expansion it will become liquid plus vapor. Then this become dry vapor, 100% dry. So these processes can be represented by an TS diagram that we discussed for formation of steam in the thermodynamics. So what is the TS diagram? T is temperature, S is entropy. So we can see the processes 1, 2. This begins before compression and after compression, process 1, 2. So this is a compression process. At state 1, what is the condition of the vapor? This is x equal to 1. So, and this line is x equal to 0. Liquid line and vapor line. So dry vapor at point 1, that means it enters into the compressor. And after compression, it is called the isentropic compression. Temperature increases, and it at state 2 it was dry at state 1 and it is superheated at state 2. So after compression, what is the condition of the vapor? Superheated vapor. Now it will enter into the condenser at point 2 and it will go to the point 3, state 3. So because of the heat rejection, this is like this is exactly condenser. What is a condenser? Condenser is a device to reject heat, to change the phase from vapor to the liquid. So that is definitely heat rejection. This is heat rejection process. This is just opposite of your boiler. In the boiler, heat absorption process, but in a condenser heat rejection process. So because of the rejection of the heat, superheated steam become dry vapor, and dry vapor gradually become liquid, 100% liquid. So this is called latent heat of vaporization, this region, and this is a mixture of liquid and vapor. So gradually if you go to the left side, amount of liquid will increase and amount of vapor will decrease, and at point 3 it is completely liquid. So the refrigerant coming out of the condenser, this is the condenser, is 100% liquid. Now it will preserve in the it will stored in the receiver. So receiver has no other function, only it stores the liquid. After that it will go to the expansion valve. Okay, this valve is called expansion valve, and the process is definitely expansion, and that is why in the TS diagram you can see process 3-4 is expansion process, and due to expansion temperature decreases. At point 3 it was liquid, 100% liquid, and at point 4 it is liquid plus vapor mixture, liquid vapor mixture. It is not dry also, it is not liquid also. That means there will be some fraction will be liquid and some fraction will be vapor. Now it will enter into the evaporator at low temperature. Because of the expansion, temperature decreases, and at that temperature it will absorb the latent heat of vaporization, and if absorb the latent heat of vaporization, gradually the amount of liquid will decrease and amount of vapor will increase. It is 100% dry, that means dry vapor, and again it will enter into the compressor. So this way the cycle repeats. So this is the description or explanation of vapor compression refrigeration system. So basically what happened in this cycle, the liquid become vapor, and again vapor become liquid, and the compressor compresses the vapor. From that the term is derived, vapor compression refrigeration system.